See the screen?
Yes, sir. Yes, sir.
Okay, I'm starting within a minute.
Sir, will you be sharing the slides for today's morning's class, sir?
Yes, I'll do it.
Okay, thank you.
Download the recording also and also.
Yes.
May I start? How many of you have joined?
Sir, 81 joined us yet.
81. Okay. Okay, then let me start because I think you are having other classes also next.
No, sir,
Okay,
actually,
so you are
what's
talking
happening,
about dynamic memory allocation. Yes.
sir, actually, what is happening is so that there are a lot of multiple meetings that have been set up, so that's why people are getting confused and probably are stuck in
My
our.
but right now I am just having one meeting.
Yes, sir. Like your meeting's name is new channel meeting, right? There are two other new channel meetings right now on
Yes.
the screen, which have been started by other students, sir, by accident because they didn't couldn't see anything at the beginning, probably. So I text them, so you can start, sir. I'm texting them, so they'll join, sir. It's fine, sir.
Just text them. Maybe before I start in a concrete form, let me take a couple of minutes. You just drop a message in the WhatsApp. Meanwhile.
Yes, sir.
Okay, so we are talking about runtime memory allocation or dynamic memory allocation, and in our last class till our last class we extensively talked about the pointers, the pointer variables, pointer constants, and different options to uh, create pointer constants and different ways of assigning the constantness to it. And we have also extensively talked about the memory layout, which is important for the understanding of uh, the layout of the code, and that is in fact true for any codes that you write, any C or C++ codes that you write or any process in general that executes in a machine. And so what we found is if a pointer variable is declared as a local to the function, so that pointer variable will be allocated space from the stack if it is local, purely local, non-static. But whenever you are allocating space and trying to assign the address of that base address of that block to that pointer variable, then the chunk of space or block of space which gets allocated, it is from the heap segment. So effectively you can think that the pointer variable which is in the stack segment is pointing towards some memory location or some block which is in the heap segment. So that might happen, or maybe it can also happen that the pointer variable. So whenever there is a dynamic allocation, this happens, right? And what we found is all these allocations, whenever something is allocated, like the memory manager, sorry, like the hotel manager or like the mess managers, they know which rooms are occupied, which rooms are having some borders and all. So here the memory manager also has got the complete list of allocated locations or blocks of locations which are allocated and which are free. And in fact, there are several interesting data structures which keeps track of these free locations. So sometimes, maybe I don't know whether you have encountered these names, buddy lists and all. So buddy list is a very interesting data structure which takes care of these free space, free blocks, and it works extremely fast with a little bit of wastage of space, but it is extremely fast in allocating space and also, you know, merging out the deallocated spaces and all. So the point is, so if we have allocated something in the heap, so if we don't call free, so that space or that block remains allocated and remains occupied in the heap. So that will be treated as a garbage because you cannot access it, you cannot use it, and the contents of that space is not meaningful to you. So this is extremely important. Whenever you go for dynamic allocation, you must be always cautious that whenever you are not needing that space, you don't require that space anymore, you should be simply deallocating that space immediately. So that as we'll find in many other applications, you really need sometimes maybe the entire heap or maybe the 90% 80% of the heap. And in that case, if you leave these garbages, it may be really difficult for you to manage, and you will find that even though there are space which is unused as left as garbage, you cannot request for further blocks. Okay, further allocation cannot be possible. This is a extremely important thing, and sometimes you find that actively you are not using too much of heap or too much of dynamic space, dynamic memory, but your program aborts because of lack of memory, out of memory, like that. So this memory layout is extremely important to map things in a more effective way. So what we had also talked about the void type. So void means it is also literally, it might mean that it is absence of everything, anything, but maybe in the context of programming it means a very generic one, which includes, which is capable of including everything. Okay, so this is what void means, and malloc actually returns void asterisk, void pointer, so that you can use it, you can typecast it and use it accordingly. So next will be so in this I think all of them, they have joined, right? I cannot see the
Yes.
numbers
Yes.
also.
Yes, sir. Joint,
Okay,
sir.
so let me start this class. So in this class we'll be talking about the two new operators which will be used to allocate and deallocate memory. Okay, so this new is something equivalent to malloc or calloc, and the delete is something equivalent to the free. So malloc, calloc and free, these are library functions, and new and delete, these are operators. Okay, so in C we have got only malloc, calloc and free for the dynamic memory allocation, and C++, because it is compatible, it supports use of malloc, calloc, free. If you want, you can do that, and it also supports, in addition to that, two new operators, new and delete. So let us see that how this can be used and what are the advantages of using this. So what will be the equivalent of so how many of you know the use of new and delete operators, those who are C++
Hello,
specialists?
sir.
Yes. Hello. Yes, tell me.
Sir, sir, I have a question.
Yes, I can hear you.
Yes, sir.
Hello.
Sir, can we explicitly cast the void pointer type to the? Yes, sir. I'm asking my question, sir.
Yes, yes. Can we typecast? Yeah, go on asking the question. I cannot hear
Can
you.
we typecast
I
the
think nobody
void
can hear
pointer
you.
type to any user-defined pointer?
Void pointer type to any user defined data type pointer. Yes, that is possible.
Oh.
You can cast it to anything. It is up to you.
Pointer type.
Yes, if you have got a so your voice is, I think, breaking. There is intermittently it is coming. So as you say, if I have declared a structure of say XYZ type, so if I declare a pointer to that structure type, which is a inbuilt, it's not an inbuilt type, it is a user defined type. Now if I've got a void pointer, I have allocated some space using malloc, so I can cast it to that type also. So what I mean is, say I have got struct XYZ, and no matter what I write here, and I write here, and in fact in C++ you don't have to use the type def, so that is something easy to write here. So if we do this, so I can write here this malloc, whatever is the space, so it may be size of XYZ. So we can write here XYZ asterisk. So this is possible. Are you asking for this? Are you asking about this? Hello?
Yes, sir. Yes, sir.
No, this is possible.
Oh.
So maybe we'll have opportunities
Sir,
to
my name.
talk about it later also. Yeah. Yeah, ask me, because there is sometimes there is no sound at all from your side. Hello? Okay, let me continue. I think so the thing is the new, so can you see this? So how many of you have done use new and delete operators? So what is the
So,
equivalent of this?
so new
Yes.
is malloc.
So new is malloc is fine, but I want the equivalent statement using new corresponding to this one. So can everybody read this? What is written here? What is the purpose here? So malloc, I am asking malloc to allocate the size of one integer variable, single integer variable, and I'm typecasting it to an integer pointer, and I'm assigning it to p, which is an integer pointer, right? So is this okay? This part?
Yes, sir.
Yes, sir.
So now what is the equivalent of this statement in new? So everybody knows C. So everybody knows the purpose of this. They can read it, right? So what will be the equivalent statement using new operator instead of malloc function here? So those who know C++, tell me the answer first.
Sir, it will be
Strict-
new int.
Sir, int star
star
equals
p
to new
equivalent.
int arr size.
Uh, new int, then
Size.
New int size. Then we need to
size.
specify the size in square brackets.
Any other answer? Those who know C++, please
So I think we don't
answer
have
it
to.
fast.
So I don't think we have to define what the size are, because int, I guess, in C++
Okay.
automatically
Yes.
denotes the space, sir.
Okay. So
New int
that's
Sir,
should.
I
the
am
correct
telling for
answer. So the
array.
thing is, in C++, no, see, I am talking about the equivalent of this one. Is it allocating some array size of
Acha,
int only?
no
That's
problem.
all. So,
Then int.
so, so what is this? So this is equivalent to this one. So I think all of you can interpret. If you know this, you can interpret this also. So what the nice thing is, this is a operator that you are using here, and this new means you are talking about the data type. So one element of data type, the space equivalent to one element of that data type will be allocated, and the base address of that will be assigned to p. So where from this space will be requested or it will be granted from which segment?
The heaps.
It will be also from the heap. So no matter what you do using malloc or new, basically you are seeking space, you are asking for space from the heap segment. So this also will be from the heap segment because this is also dynamic allocation. Why it is called dynamic? Because this memory, how much it is required and the amount, everything, or this actual allocation will take place once the program starts running. So before the program starts running or the initial stage of the running, the heap is completely blank. As you start executing the statements, as you execute new operator or malloc, then only the allocation takes place. So that's why we call it as this is dynamic allocation, or sometimes it is also called runtime allocation. Once it starts executing, during the runtime we are allocating. But this p, you see, int asterisk p, it will be within some function main or whatever, f1 f2. So because this is local to a function, this will be from the stack. So this is not in a runtime request. So this is a static allocation. So that's why we call it as this p will be static allocation, and the space pointed by p will be dynamically allocated or it will be allocated in runtime. So this is what is meant as dynamic or runtime allocation. And you can see that through that animation in the last class, we have seen that as it executes, how allocation takes place, it goes off and all this. Okay. So one nice thing that we can see is we don't have to calculate explicitly the size of the integer. It can, so the C++ compiler can quite well decode from this data type itself that what is its size is, right? So now what is the equivalent of this? Now it says that, so this space which P points to in both the cases, this space remains uninitialized. If I would like to allocate as well as initialize in C, what we need to do? We allocate and then we write asterisk p5. We allocate a float point space equivalent to one floating point variable and then we initialize. Is that fine?
Yes,
Hello?
sir.
So what will be the equivalent of this here in C++? Tell me the answer. New int. So now I would like to initialize. So in C++, the advantage is we can not only allocate the space, but also initialize it if we want, which is not possible in C in the same statement. We have to have separate statements. So how should I do it?
Sir, int start
Here.
p new 5.
So we'll have, through this we can initialize, right? Allocate and initialize. In case of floating point, so we can have the same thing, new float 5.8. Is that okay? So it is the data type and this is the operator and this is the initial value. So keep in mind this type of parenthesis. Is that okay? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Others it is fine. So now let us see that. So we just allocated space. Here we allocated as well as initialized. Now what I want to do, I want to have a block of allocation. So I would like to allocate a space for n number of integers, right? It's an array of integers. It is something like this. So I would like to have p pointing to a block of integers. Here it was just one integer. Here the thing is it was allocated and it was initialized. It was not initialized here, and here it was uninitialized, but is a block of space. So for that we write malloc size of int into n and all this. So what is the equivalent here? Can somebody tell me? Can somebody tell me this answer? I would
Sir,
like.
int start p new int arrn.
So new
New
int and then
int.
size in square bracket.
Right? Hello.
Sorry.
Yes, sir.
So it's a block of or a set of integers. So can each one of you see the difference here? See the difference between this and this? Can you see the difference?
Yes, sir.
Yes.
The type of parenthesis that we use. So if you use this type of parenthesis, this means you are trying to initialize one space for one element of float type, and here it means, or integer type, and here it means, in this case it means you are trying to allocate space for n number of integers, and you are not interested in initializing because it is not possible now. You cannot really allocate a group of space, a group of elements, and as well as initialize. That is not possible. Okay. So now what is the equivalent of free? What is the equivalent of free? Free p means what? What I know? It deallocates the contiguous block of space pointed by pointer p. So in this case, if I deallocate, if I call, so this free, if p was pointing to this space, so if I call free, so this will be deallocated. What does deallocation means? What does
So the no
deallocation
longer,
mean?
so the memory is no
Mhm.
longer assigned to the pointer p, sir.
Now, so it means that the memory manager will note it that it is now free for allocation, further allocation. So it is like checking out rooms, right? When you check out rooms in your hotel, what happens? So the front desk, they just keep a tag that okay, this room is now available. So they will ask the room cleaning boys to clean it up, and it will be available for further allocation, right? So these all are from heap, right? This is all from heap. These are all from heap. And free means you are allowing that space for further allocation. It is no longer in use by this particular process. So what is the equivalent of free p here? It should be, sorry, it should be
delete p.
delete p, right? So this is what it means. Will it work? If I write delete p, will it be equivalent to this free p here?
Mm, sir, we have to use a square bracket, sir.
Yes, good. So what it means, so this, so see the difference. So there is one this delete and one this delete. Delete p. So this is, there are two type of deletions that are possible, A and B. What this delete p means, see carefully. This delete p means you have got a block of space, right? And it deletes only the first location pointed, first element pointed by p. Got it? And here this means, in this case, in second case, this means if it is p, then the whole thing is deallocated. So this implies this, and this implies this. Are you getting the difference? Everybody, are you getting the difference here?
Yes, sir.
Yes, sir.
So if you just write delete p, you assume that it is actually not free p. So free p is, so this is equivalent to free p, right? What do you expect in free p? But this is not equivalent to that free p because it is just deallocating the first element of that, chunk of elements or the set of elements that you have allocated in one shot. Have you got the difference? Hello?
Yes, sir. Sir, I had one doubt, sir. Sir, in case let's assume that in free p is a pointer that points to an array, but the first element is empty. Like it's like there's nothing there in the first element, but the array starts on the third element onwards. So in that case, sir, delete p, would it delete
See,
the
so what do what do you mean? My question, what do you mean by empty here?
sir?
This is a space. Say for example, five of your friends, they have blocked a room. I mean, they have booked a hotel, right? And they say that we want to have consecutive rooms, right? That now maybe two of them. So you have booked it, pre-booked it, and so you have got the allocation. So when you go there, they say that okay, you occupy from room number 5 to 10. That's all. Now maybe two of the friends, they left the next day, or maybe the next yeah, so the next day they leave, but the rest of them they're staying. So definitely the first two rooms will be empty. So that is what empty means. But the thing is, because it's a block allocation, probably you have to deallocate also as a block.
No, sir, in that case, if I'm not doing deallocation of the entire block, I'm just writing delete p. Sir, will that be the first on unoccupied room, or will it be the first occupied room, sir?
See again, what I mean, occupation, I mean, whether it is occupied, whether it is not, this is so this is not so this is completely a it's a logical aspect. So once it is allocated, whether it is occupied, whether you have kept something, whether you kept garbage, it is up to you.
Okay, sir, got it, sir.
It
It's
says
not.
that it is allocated. So, so it says that you have just allocated, you have got this allocation. Now you are, this part is not you are currently actively using, that is up to you. So to the memory manager or to the operating system, it knows that whether you have allocated it or you have not allocated it. You have allocated, you have booked say a block of 5 rooms, but you are not using all the rooms. It's up to you, but you have to pay for it. Or in other words, the hotel manager will not be able to allocate somebody else in those rooms that you have already booked, right?
Yes, sir.
Hello, sir. Hello.
Yes.
Yes, sir. If I wanna delete any null space or something like that using delete, then will
you,
there be
you,
any?
you speak a bit louder. Your microphone is not working properly. Yes. Hello. Ask the question. Don't waste the time. Please go on and ask the
Hello.
question.
Hello.
These are all trivial things. I'm going to get you to the actual things. These are all very simple things. Please ask the question fast.
Yeah, sir. If I wanna delete any null, if I wanna delete any null using this delete, then will there be any kinds of error or something like that? Means
If this p is pointing to null,
yeah,
if p is pointing to null,
if
right?
people, yeah,
Yeah. So yeah, some compilers might be, so it might give a fault because the thing is you have not allocated, so you have not checked in at all in the hotel, and you say that I want to check out now. So does it make any sense? So it depends on how the compiler is going to handle it. So this might be this generally will give a error message. But again, this error message will be given in the runtime itself. You cannot, because in the compile time, this is nothing to do with the compile time. So during the compilation there will be no errors. But when you start running, if by chance you are trying to deallocate the the space pointed by a pointer which is assigned null, so you can expect that you are not allocated but you are trying to deallocate. So you will get an error message. Got it?
yeah. Thank you, sir.
But what will be the error message, that depends on the compiler, how it will display, and what exactly will be the error message, that will differ. So in fact, in my case also, I have to run it and I can show you what will be exactly the error message. But it will be error message. Is that okay?
Yes, sir. Thank you, sir.
May I proceed?
Yeah.
So these are the things that I have just now mentioned, right? So just have a look into it and then sum up the advantages of using new and delete over malloc and free. So what are the advantages? Now do it fast. Don't take so much of time. Sum it up. What are the advantages of using new and delete over malloc and calloc? What you felt?
Sir, first in writing of code, sir.
Writing? See, first of all, we don't have to mention the size of the element, right? That is not required. And
Yeah.
second thing is, in the same statement, you can initialize as well as allocate. Allocation and initialize can be done simultaneously. This is second advantage. Third advantage is this delete works in two ways. There are flexibility in deletion. You can delete only one element, the top element, or I mean the first element in that block, or you may delete the entire block. But there is one more important advantage. So these are somewhat trivial, right? The initialization during allocation, size of element not required, and another important point is no typecasting is required. Do you need any explicit typecasting here or here? There is no typecasting to integer pointer or float pointer. So these are all done, but these are done in a very abstract way. It is done internally, right?
Yes, sir.
So two options are there for deletion. So these are all trivial ones, but the important one is we can, because new is so new and delete, these are operators, right? So we know that operators in C++ can be overloaded. So we can exploit that feature of C++, that is operator overloading, and we can overload this new operator for user defined classes also. So probably you have written a stack class, you have written a matrix class. So in that stack class, you can write a operator method which overloads new, so that from that point onwards you can write new stack 4. So what will be the interpretation? What do you want to do here? What is the interpretation of this statement? This statement allocates what it does here.
Make a stack of size 4.
Sir, array of stacks.
Stack of
Actually, stack of array.
yes.
Array of stacks.
Why is stack of size? So this stack is a data type. So how many, and whenever I give this type of parenthesis, you see this type of parenthesis means this is a block of, so it's a array of 4 stacks. So you are allocating not only just one stack, you are allocating 4 stacks in one shot. So the 0th stack is so the 0th element is a 0th stack, the first stack, second stack, third. So 4 stacks you are allocating, and definitely you cannot initialize them there itself, right? And you can do all these allocation of these stacks in the heap segment dynamically as you wish. I mean, as much as you need. And here, how many matrices are allocated in one shot?
4, sir.
4.
Hello? 4 matrices. Now you say that, okay, 4 matrices, but what will be the size of the matrix? What will be the size of the stack? Well, maybe we should defer such detailed discussion right now, because those who know constructors, they know that there are ways to specify it using default constructor or using default values in the constructors. But yeah, right now let us say that it will be done somehow. Let's not worry about it, right? Because you know that matrix. So you say that okay, you allocated four matrices, but what will be the size of each matrix? Can we have varying size of the matrices in each of the 4, or do they all need to have the same size? So we'll see about it later on. Even in the stacks also, will they have all the same size, and what will be the size? So all these questions will come, but the thing is, you should know that any user defined data type, a polynomial type, a stack, a matrix, a tree, a queue, whatever, you can, when you write that class for that particular data structure, the class definition for that, you can add a operator function with respect to new, where you can have the provision for this, and so that dynamic allocation of those stack object of those class objects will also be as it at ease, right? Is that okay?
So can we specify
Is that fine?
default value while we are allocating arrays? Can we specify default values to the array?
Yes,
Array
yes,
element.
we can do that. Yeah, we can do that, but let's not get into the details right now. Definitely, we can do that. Okay. For the let's have this much for the timing. Otherwise, it will be because there are many of the students. I mean, in fact, majority of the students who are not familiar with C++. So you should not continue with you should not skip things right now. Yeah, that can be done, and you all will know it maybe after a few classes. So this is not a big deal. Just hold on. Is that okay? Any other related questions? Hello. Hello.
No, sir.
Okay. So now, so this dynamic allocation of 1D arrays. So this is pretty simple. So what I have done, you just look into the code and try to find out what it does. N equals to 5, new int. So what I did here, what is the purpose of this statement?
Making an int array of size n. मतलब, making an int array of size n.
So allocating an, memory enough for an array of size n.
Yes. So it's a sorry. So this symbol means you are allocating a block of integers, right? How many? N number of integers. What is the value of n? N is 5. So it's basically an array of one dimensional array of integers of size n, right? So this is what it means. It's very simple. Now here, once I have done the allocation, I can write pi equals to pi plus 10. So what I am essentially doing here, each element of the array is added to 10, right? So what was the default? So there was no initial value assigned to those to that block which got allocated, right? So what do we expect?
0.
This is a 0, this is a 1. So this is 0, but this is not always, it is not recommended. So you should initialize it and then only you can use it. So in this case, you can see that without even initializing, it is getting the values 10, 10, 10 like that. But this is not recommended, right? But well, this is what it works, and then it displays. We have used the cout statement suitably using cascading, and it displays these nice formatted elements, right? So instead of pi here, if we write p plus I asterisk, will it work instead of writing pi directly? And
Yes,
here
sir.
also, if I write p plus I asterisk,
Yes, sir.
will it work?
Yes,
It will work
yes,
because
sir.
we all know that. So here also, it doesn't matter whether it's pointer notation or array notation, both will work, right? What we have done here, this value of p or whatever p is pointing, so these b another, so b is another pointer. So this is b, so this was p and this is b. So now I say that b is also containing the value that is contained in p. So b and p both points to the same location, right? The base address. So that is what I have done. And then here I write delete p. What it does in this stage?
Deletes
It will
the array.
deallocate.
It delete
It
the
will
entire array.
deallocate. So see, both p and b are pointing to the same location, right? The base address of that contiguous chunk. Now when you write delete this p, so that means this will be completely deallocated. So now what happens? If you write cout b0, what do you expect here? Cout b0.
Sir, error will
Garbage.
come.
Hmm?
Garbage,
So it is
garbage,
basically
error.
garbage. So don't treat this 0 to be something that is meaningful and you can use it. Don't rely on this. That's the point. You might be happy that okay, it has reinitialized to 0, but nothing has been reinitialized. Nobody knows what is there. Okay, so don't rely. So this is basically garbage. So you say that I intentionally clean the garbage because I am about to leave that function, and this is a good practice. But once you have made a garbage, you should not try to access the garbage and find out something useful. Right? So here, can you just tell me quickly that which of these portions will be allocated in the heap stack segment? Which of these variables will be allocated in the stack segment? Quickly.
Sir, N.
Sir, N. Sir,
N,
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 P,
P, and
P,
N, P,
I.
and B and I, right? Is that okay? Because these are all, you see, local. No matter it's a pointer variable, it's a normal integer variable, it's a floating point constant, whatever. So these are non-static local. This, this, and this. So that's why they all will be, getting space from the stack segment. And how much will be space because of new one, new. So how much space will be there? So it will be, so this much space will be from the heap. So this is n integers, space equivalent to n integers, and this p will be actually pointing to this one, or at this point b also will be pointing to this one, and at this point you will be deallocating the space. So that is what it happens, right? And in fact, I have intentionally not shown the data segment to avoid the mess, because there is no global, there is no static that is there, so it will be left blank, right? But even though you don't have anything to allocate, but the data segment will be a part of your memory space, of your program's memory space, that you should always remember. So the data segment is also here, but it will be left blank. Is that okay? Hello?
Yes, sir.
yes, sir.
Yes, sir.
So now allocating 2D arrays. Now when you have 2D arrays, now you say that I would like to have int a is the number of rows and the number of columns, right? So these are the rows that you all know, and these are the columns. Now when you go for dynamic allocation, if both R and C are known, do we really require dynamic allocation? If we know the number of rows and the number of columns, which will be remaining fixed throughout the execution, or which will always be the same in each and every execution that we make, if both R and C are known fixed, what type of allocation we prefer in that case?
Static.
Static allocation. So it is something like you write int a 2,5, and you know that no matter how many times you run, you will always be using a 2D array of 2 rows and 5 columns. But if this may not be the case always, right? Sometimes you say that I am not sure that what will be the number of rows and number of columns. So this R and C in this case both are unknown, and they will be known in runtime. That means when you run the code, then you ask what is the number of rows, then you ask what is the number of columns. And in that case, because the size is not known to you, if the array size is not known, if you know it in runtime, you probably will be asking for the space for the array also during runtime. And in that case, you cannot allocate the space for that array in the stack segment as it is here. You are forced to allocate or get the space for the allocation from the heap. Is that fine? So can you tell me, if the number of rows and number of columns are unknown, then how to allocate? I mean, first of all, what will be the type of the pointer? What will be the type of the pointer which will be used to point to that space that hosts this A of RC, like this one?
Pointer to pointer.
Pointer to integer. So this is P, right? So what will be the statement using new to allocate the space? What will be the statement?
New in A.
New int,
In
new int,
A.
New in no sir.
Why?
Square bracket, and then R and then square
Size
bracket.
of R and C.
Size of R and C. Say, let us assume that we have done this. So now what we write? What do we write here?
Square
What do we write
brackets
here?
RC.
RC. What it means? R?
R into C.
R into C. R into C. Will it work?
No, sir. We have to write square bracket again.
Sorry,
Sir,
inside
both
one square bracket R and then C, I think.
Like this.
separately, sir.
Yeah, I
Yes,
know.
sir. Yes, sir.
Yeah,
Yes.
that one.
But write this one. Hello.
Yes, sir.
Yes, sir.
So do you think that it will work? Let's see. R and C, and let us have say, okay, let's put it in comments.